Right now, thousands of businesses are unknowingly locking their critical workflows into AI software that is already structurally obsolete. The underlying models driving these platforms are advancing. When a general foundation model absorbs a highly specialized function as a native feature, the dedicated standalone tool built for that single task ceases to be necessary. To understand the speed of this shift, we have to look at the physical tech industry, because this exact cycle of consolidation has happened before. For decades, if you needed to perform complex math, you bought a standalone calculator, a dedicated piece of hardware engineered for a single, isolated function. Taking photos required a digital camera, another isolated unit with its own battery, storage, and interface designed specifically for capturing images. Navigating a city meant mounting a separate GPS receiver to your dashboard. It required entirely separate infrastructure and a distinct data connection just to update maps. The smartphone instantly consolidated these fragmented tools into a single device, reducing decades of specialized hardware to a row of digital icons. Those specialized devices didn't disappear because their math was wrong or their lenses broke. They lost their market position because their core utility was downgraded from a standalone product to a built-in feature of a broader ecosystem. That exact physical consolidation is currently mirroring itself in the AI software landscape. This expanding sphere illustrates how general foundation models have rapidly scaled reasoning capabilities. As these systems grow, their radius widens, overtaking specialized markets. When a foundation model expands, applications functioning strictly as thin API wrappers lose their structural advantage. To expose how fast this shift is happening, we can audit 7 specific categories of AI tools that are already showing clear indicators of obsolescence by 2027. Securing a workflow over the next few years requires distinguishing between software that offers a genuinely specialized product and software that is merely a temporary patch for a feature general AI hasn't mastered yet. We start with Category 1, standalone grammar and basic writing correction tools. For years, these platforms operated on rigid syntax rules and basic text replacement logic. You wrote elsewhere, then pasted your text into their system to catch structural errors. Today, general-purpose AI writing assistants handle comprehensive contextual structuring directly at the operating system and browser level. The correction happens continuously in the background while you write. Category 2 covers basic AI image upscaling and enhancement applications. These algorithms were designed solely to increase resolution or fix lighting, but utilizing them forces you to break your creative flow, export a file, run it through a separate tool, and re-import it. As this diagram shows, comprehensive visual platforms now execute generation, editing, and upscaling within a single continuous loop. In both text and vision, isolating a basic correction phase from the actual creation process creates friction. Unified generation eliminates that friction completely. Category 3 examines simple chatbot builders tailored for basic customer service. Early generation bot builders relied entirely on rigid decision trees, requiring teams to manually map out hundreds of conversational flows. Modern platforms integrate general models that dynamically adapt to context, extracting semantic meaning without pre-programmed paths. That same lack of semantic understanding brings us to Category 4, standalone meeting transcription tools. Converting raw speech to text used to be a premium service. Now, dictation with zero contextual intelligence is a widely available commodity. Advanced meeting assistants surpass simple dictation. They read the context of the room, automatically extract specific action items, and synthesize data across months of prior meetings to build an active organizational memory. Software that simply records data cannot compete against foundation models designed to actively process and recall the meaning of that data. Category 5 targets single-purpose content idea generators. Tools built strictly to generate headlines or spin prompts hit a hard limit because they operate in total isolation from the actual execution of the content. End-to-end platforms treat ideation as the first node in an unbroken pipeline. The context established during the brainstorming phase flows directly into the research and drafting phases, maintaining full alignment. We see this exact limitation again in Category 6, basic keyword matching SEO tools. The old methodology of search optimization relied on scraping algorithms to count exact match keyword density. Modern AI platforms natively evaluate true search intent and semantic quality, aligning with how search engines actually rank information today. Breaking research apart from execution negates the primary architectural advantage of modern AI: sustained contextual awareness across an entire project. Finally, Category 7 addresses simple template-based design tools. These systems offer a modular approach to creation. You select from a library of fixed layouts, drop in some text, and apply minor customizations within strict boundaries. Generative AI platforms bypass templates completely. By rendering custom, highly specific visual assets directly from text descriptions, they eliminate compromising with pre-existing layouts. When generating a bespoke 0-to-1 design requires the exact same computational energy and user effort as selecting a restrictive template, static asset libraries lose their professional utility. Understanding which tools are expiring allows you to clear the deck. But the real advantage lies in applying a specific framework to evaluate your software investments going forward. Rule 1 is the data moat test. For a tool to maintain long-term value, it must possess genuinely specialized infrastructure or proprietary datasets. Merely wrapping a user interface around a general API is a critical vulnerability. Rule 2 is the horizon test. Software must continuously expand its operational scope. A tool that remains functionally static over several months is likely waiting to be absorbed. Rule 3 concerns workflow dependency. Relying on single-function API wrappers for critical business logic creates a fragile operational chain that can snap the moment the underlying model shifts. Rule 4 is foundation model leverage. The most resilient platforms are built directly on top of rapidly improving general models. By utilizing this leverage, these platforms automatically upgrade their capabilities every time the underlying foundation advances, requiring zero manual rebuilds to stay competitive. Rule 5 is the quarterly audit. Reassess your software stack every 90 days to identify which standalone tools have been quietly overtaken by native features elsewhere. The professional edge in this landscape doesn't go to the operator who stitches together 50 disparate specialized applications. It goes to the operator who deeply masters a few comprehensive platforms. Ultimate operational efficiency no longer comes from assembling a fragmented software stack. It comes from architecting unbroken workflows on unified foundation models.